So when I first started talking to this community, your community, our community, one of the things I first brought was water. I started talking a lot about water, and I got to say, I carried that work on. That work was sort of passed to me from David Wolf, who started me on that path, and I've been carrying that message for a long time. And it's been a few years for me, and I've got to really, you learn a lot from research and you learn a lot from study, but you learn the most from time and sitting with a thing and meditating on a thing. And I want to share with you what I've learned about water over the years, where I'm at today in my personal development and my understanding. And if I do a good job of this talk today, I think you'll understand water in a really new way by the end of it as well. So the name of the talk is Water Shamanism, because we're in this age of science, or we think we are. I don't know. We're in a left-brain scientific mindset. But most of the world's been in a more of a right-brain kind of shamanic mindset. And when you start talking about water and you're operating from the chemical mindset, you can easily downplay maybe the most important element in our lives. And I want to talk about water today scientifically, but I also want to talk about it as an element. Does everyone understand what I mean by element? I don't mean carbon, hydrogen, oxygen, 92 elements, periodic table, boring science class, chemistry. I mean element. How many elements are there? Is there 4? Is it 5? You know, the whole world has operated off this idea of elements for a long time. The elements I'm talking about, earth, air, fire, and water. Those are the real elements when you engage with nature. It's easy to forget that when you're living outside of nature. I know it is. So I call this water shamanism because I feel like the goal is that you become a shaman of water. A shaman's somebody who can kind of engage with another layer of reality, like almost what we call the spirit realm, and somebody who carries a teaching with integrity. And if you integrate this message today, then you can kind of carry it out and you can be a steward. You can steward the living liquid crystal. That's really the matrix of life. That sounds so esoteric. All right, let's get. Here's a question. What is water? We have grown up around such abundant water, we maybe haven't even stopped to think about what it is and how unique it is. You know that in physics, if you're a scientist and you're studying water at any level, water is the big anomalous substance because it doesn't actually even conform to our current laws of physics. It's not even understood. Okay, so what is water? A couple things. Water is a strange and anomalous transparent liquid, a liquid mineral. It's like a stone, but it's a liquid. It's a liquid mineral. And it defies the generally accepted laws of physics. We see it in all of its phases of energy or all its phases of matter. We talk about states of matter. And I think another way to understand states of matter is to say phases of energy. They mean the same thing. But what's unique about water, water is the only substance that you can think of that's natural, that you can see in one place on Earth as a liquid, solid, and gas all at the same time. You don't run into like, wow, there's some liquid steel and gaseous steel, and over there is like some solid steel. You don't see that with salt. You don't see that with... Water is really the only substance we encounter in all three states of matter anywhere. So you can be in a place where I live in Maine, a couple months from now, you can go to a place where there's frozen water on a stream, and then there's running water, and then there's clouds above you, and look at that. That's 3 phases of matter, all in one place. That's rare, and no other substance does that, and it's not really understood why it does that. It also has an unusually high specific heat capacity. It's got more than any other substance, it resists temperature change. Water's just strange like that. If you've ever taken a steel pot and heated it up, you realize it heats up real quick. If you put it on heat, and it cools off real quick. But if you've ever drawn a bath, you notice that the water gets hot, you leave it in the bathtub a couple hours, you come back, it's still warm, cools real slow. It's one of the unique properties, and without that, we wouldn't be alive here, and I'll explain in a bit. Water has this unique property that what's it do when it gets cold? Shrinks like everything else till it hits a certain temperature, right? 4 degrees centigrade, 32 Celsius, it does something totally anomalous. What's it do? Expands. You ever break a water bottle in your car in the winter? If you use glass bottles, you'll do that from time to time. Or you ever put water in the freezer or any liquid, which is really just water, in glass in the freezer, and you can shatter the bottle because it expands. If it didn't do that, there'd be no life on Earth, and we'll talk about that as well. It's really what if you imagine if water just got smaller, smaller, smaller like other substances when it gets cold, then all the ice would end up where in a lake? The bottom. And then it would freeze its way to the top, and there would be no more fish. What happens is it actually, the cold water sinks, and when it freezes, it floats to the surface. And then it insulates the water in the lake, and that's what allows fish to live. That's a unique property. It's not really understood why it does that. It's the universal solvent. It's the solvent all life forms use. In other words, you're made of, and every other life form you know about is? And do we know any exceptions to that? No. Maybe life is water. Maybe each one of us is just a different expression of water. Water has an absolutely unusual surface tension. And the weirdest thing about water to me is it's the only inorganic liquid in the world that we don't manufacture. We've learned in science how to make some liquids. But check this out. All the liquids that you'll ever encounter in nature, it's just water. The only liquids that are exceptions to that are made by organisms that are made of water. So if a sugar ferments, you can get liquid alcohol, but that was really made by things that were made of water. Or you can get olive oil. Olive oil is like a liquid, but it's just made by olives, and olives are made of. But aside from that, in the natural world, you don't encounter puddles of anything. You know that every substance here on Earth is either a solid or a gas. You know the whole idea of flowing like water? You heard Bruce Lee's final interview? Anyone heard that before Bruce Lee passed on? He kind of left a really awesome interview where he's like, you must learn to flow like water. And the reason he's saying that, we don't say flow like other things. We talk about water because water is the only thing that knows how to flow. Everything else is either locked up as a solid or gone into the atmosphere as a gas. Water's very unique substance. So there's this really interesting question, where's water come from? Because most of the water that's here on the earth has been here a really long time. And we're not even sure why it's here, because it's hard to find it in concentrations on other planets. And so we know we're on a pretty unique planet from what we can see, and we're not even really sure where the water came from. I have some ideas about where it came from. But I'm going to get on the Bible verse thing again here. This is right in the beginning of the Bible. So this is verse number 2. What's verse number 1? Anyone know? In the beginning, God created the heaven and the earth. Now, here's verse 2, second most important part of the whole thing. And the earth was without form and void. In other words, the earth was like nothing. And darkness was upon the face of the deep. All there is darkness, emptiness, and void. Then the Spirit of God moved upon the face of the waters. So there's no light, and there's no earth. There's just God and water. That's the Christian mythology says that the first matter was water. By the way, it's not just the Christians. You can go around the world and talk to people, and they'll tell you the first substance in all these traditional cultures, first substance was water. Water's the source. The word for spring in French is what? Source. So that's from the Bible. Here's some science. After molecular hydrogen and carbon monoxide, water is the most abundant molecule in the universe. In the universe. It's also the most abundant solid substance in space. Think about that for a moment, please. If I said, what's the most abundant solid substance in space? You might think, well, planets. Rock of something, it's water, ice. It's the most abundant solid substance in the universe. Wow. Maybe it's not that rare. Maybe it's everywhere. So water is actually, and this is really interesting, water is burned hydrogen. Water's actually like an ash. You ever burned wood before? And you end up with ashes at the end. You burn hydrogen gas, guess what you end up with? Water. Wait, everybody. You burn hydrogen gas, what do you end up with? Water. Yeah, that's why, that's that idea of the hydrogen fuel cell car. What's the byproduct of burning hydrogen in a car? What comes out the tailpipe? Water. New water. Water is burned hydrogen. Hydrogen's the most abundant element in the universe. 90% of the atoms of the whole universe, 90% of the known universe is made of hydrogen. And then what's the most abundant solid? Which is actually hydrogen. Now, 70% of our sun, I know this may seem like we're going to get off the chemistry in a second here, but 70% of the sun, where all the light's coming from, 70% is hydrogen. 70% of the sun is hydrogen. Do you know what 60% of the earth is made of? Oxygen. 60% of our planet is oxygen. Think about this. If the sun is made of hydrogen and the earth is made of oxygen, and anything the ancients told us about male and female dynamics is true, what does the union of the sun and the earth make? See, all day long, what's coming out of the sun's made out of plasma. It's plasma state hydrogen. And what's happening is that hydrogen is blasting out as to what we call the solar wind. You've heard of that. You've heard about solar storms and sunspots, right? And the emissions that come from the sun. All day long, the sun is blasting out hydrogen. And it's hitting an earth made out of oxygen. And to protect us, we have a magnet for an earth. And the hydrogen ions blast into this wall, and it moves, and that wall is made of a lot of ozone, which is oxygen. And what happens is it directs it around. And it's possible that in that process, the lovemaking between the sun and the earth, Father, Son, Mother Earth, it's possible that the child they produce might be water. It's possible that the reason that so much water accumulates at the poles as huge crystalline ice structures is because in that process, that water that's being formed comes and rains down on the poles. Does that make sense? It's like a union of opposites. It's really beautiful. Water is hydrogen. That's why hydro means what? In Genesis, to produce. Hydrogen means produces water. Produces water. Water is the ashes of hydrogen. By the way, I want to talk about a really dangerous chemical. And you guys might not know how important it is that we need to really get on banning dihydrogen monoxide. It's the invisible killer, DHMO. Dihydrogen monoxide kills people every year of acute inhalation. People breathe this stuff in and they die. Anyone know what dihydrogen monoxide is? Yeah. People do die every year of drowning. That is acute inhalation. Laugh, that's a joke, come on. Dihydrogen monoxide, it's funny we don't think of water in that way, but if we think about water as dihydrogen monoxide, in other words, di means what? Two, and hydrogen, and then mono means, so it means two hydrogen, one oxygen, right? That's what water is. If you take two hydrogen and you burn them, what do you get? Okay, who remembers this? What is that? The Hindenburg explosion. You know, at that time they were filling blimps with what kind of gas? Hydrogen. Okay, now, use the science we just went over. When that thing blew up, it was full of hydrogen. That hydrogen reacted with oxygen. That's what burning is. When the Hindenburg exploded, what was formed? New virgin water. Most of the water on this planet's been here since the formation of the Earth. They're new, virgin, brand new, first formed, baby, infantile, immature water molecules were formed and rained down from the sky. Isn't that amazing? What about that one? Remember Kristen McCall from the Challenger explosion? When the Challenger space shuttle exploded, it was hydrogen gas, and what happened was new water was formed. It's really interesting. Water is burned hydrogen, and hydrogen's what the universe is made of. In other words, the entire universe, 90% of the atoms in the universe are water in another form. It's water that hasn't burned yet. Is that interesting? Is that interesting? I think that's really interesting. Water is really unique as a substance because, you know, it's only a liquid in a really narrow range of temperatures. We talked about how difficult it is for other substances to be a liquid at all. Most substances want to be a solid or a gas. It's hard to get one to be a liquid. Water is only a liquid between 0 degrees Celsius and 100 degrees Celsius, right? Below 0, it's, and above 100, it's gas, it's steam. So really, for there to be liquid water on the Earth, you see how small the temperature range that the Earth must occupy is? Because in space terms, we have stuff from almost absolute zero, where all molecules are so cold they almost stop moving, all the way up to the temperature of stars. 0 to 100 Celsius is like a little tiny, narrow temperature range, but we just happen to live in exactly the right place. If you moved the Earth just a little bit, the place would be solid or it would be gas, like the other planets. We happen to live in exactly the right spot. If you look at that middle star over there on the left, that's the equivalent size of our sun, and where that blue planet is in that wet zone is the Earth. If we had a bigger sun or a smaller sun, or if we were in a slightly different spot, there'd be no life. We are cradled in exactly the right place for there to be liquid water, because what you actually are, what every life form actually is liquid water. The planet that's covered in a hydrosphere, that's all the water that's here, and it's that many gallons. I don't know how to say that. You know, you've heard that thing that 3/4 of the earth is covered in what? Water. In what? Water. Yeah, 3/4 of it. But the map that we usually look at, because we're anthropocentric, we usually look at maps of where we live. So maybe we don't notice. But you ever seen the earth from the Pacific side? That's the Pacific Ocean. That's not changed. That's not modified with computers. That's the Pacific view of our earth. You can see Mexico, right? Baja, Mexico up there in the upper right. And what you're seeing down at that other end is like Polynesian. We live on a little island, by the way. We like to talk about our different continents, and we like to talk about our different countries. We actually all live on a little island on one side of the earth. See that? It's perspective, right? Wow, there's a lot of water here. This is a unique planet. And if we were even in galactic terms, if we were even a couple inches away, then it wouldn't be like that. There's like a force of love keeping us here. It's really amazing. We're really blessed. So that's the hydrological cycle. You know, the hydrological cycle is the largest movement of any chemical on the earth. Water is moving all around the earth all the time. And a lot of us remember from school learning about the hydrological cycle, and we learned about evaporation, condensation, cooling, rain coming down, filling the oceans and lakes, and then evaporating back up. And that does happen. But one of the things we didn't learn about then, because it wasn't considered as important because we weren't starting to dry up as a planet yet, was this other part. It's infiltration. And you can see that in the lower left corner there, where the water's infiltrating back down into the earth. And that fills up the aquifers. That's our underground water storage tanks. And that's where springs come from. And you can see there where it says spring, where the water's coming back up out of the ground. Water that stays on the top part of the hydrological cycle, the evaporation, the raining down, the evaporating, the raining down, it concentrates all the chemicals and all the pollution that we're putting on the earth. But I want you to think about what happens when water infiltrates the ground. And by the way, it can take thousands and thousands of years for water to get down into those aquifers sometimes. Think about a water filter. Everybody seen a Brita water filter before? So it's like basically like a little piece of plastic with some sand in it, right? And it will clean water to some degree. So think about what the earth is doing. When water that's polluted, say acid rain, falls down on the ground, and the first thing it's got to go through is the atmosphere, which pulls off a lot of the pollution that's in it already. And then it hits the ground, where it's treated by soil, a living organism. Soil microbes, roots, funguses, and it's cleaned up a lot. And then that water makes its way down through sand. 60 feet of sand is a water filter, by the way. Makes its way down through sand. Eventually, it makes its way down through clay deposits. Does clay detoxify things? So it makes its way down through detoxifying clay. Maybe even through carbon deposits. Does carbon detoxify things? Yes. Makes its way down through carbon deposits. Finds its way down into an aquifer where it sits in the darkness and the cold for thousands of years. Then slowly, and as David's probably been talking about levitationally, water makes its way back to the surface as a spring, right? And then you go to the spring and you get some water, and that water might have been underground for 10,000 years. And 10,000 years ago, was there BP oil spills? Yeah. So that water might be the cleanest water in the world. Might be. I think it is. But you know, water, what I want to talk about is that water's a crystal. And a crystal, like what's a crystal? Picture crystals. Everyone close your eyes for 1 second. Close your eyes, picture a crystal. A diamond, a quartz, whatever you want. Picture a crystal. Got it? Here's what a crystal is in molecular terms. A crystal or a crystalline solid is a material whose atoms or molecules, in other words, the little building blocks of the material, of the quartz, of the diamond, the molecules or ions, whatever it's made of, are arranged in an orderly, repeating pattern, extending in all dimensions. In other words, a crystal is made up of little parts that are really organized in every direction. They're not random. That's why it's a crystal. And a crystal, the molecules are arranged in a formation. There's an orderly formation, and that word formation is where we get the word information. And information means something's organized in a formation, right? And that's why crystals can transmit information and store information, because your computer chip is made of crystal. Silicon crystal, quartz. In the future, it'll be made of diamond and water. Because crystals storing information and transmitting information is not just a hokey, new agey Sedona thing. It's also what makes your MacBook work. It's what makes your iPhone work. That is totally advanced new age technology. That's all that airy-fairy new age stuff applied to science and made to work. Crystals store information. Crystals transmit information. Now, water is a really interesting dipole molecule, and what happens is it's a balanced molecule in its electrical charge, except those two H's are kind of like boys, and the O is kind of like a girl. And what happens is the O side is a little bit attracted to other boys, and those two H sides a little bit attracted to other girls. And when you get them all together and they're all hanging out in a little water party, they start to align themselves. Can you see that? And if they align themselves, because of almost like the way magnets, the North Pole's looking for what pole? South. Water's like that. The North Pole of water is looking for a South Pole of another water. And if you get a whole bunch of water together, it wants to organize like that. That's two ways of looking at the molecular arrangement of crystalline water. Now, we see that physically with our eyes when we see water in the form of ice, right? Snow, crystals, snowflake. Snowflake look organized to you? Looks organized to me too. But we don't notice it with liquid water because water to our eye is transparent liquid. So we don't see that it has structure or organization to it. I'm going to give you guys a little bit of an analogy. Here's two substances made of the same thing but are very different in behavior. On the left, these are molecules of silicon dioxide. That's a molecule not unlike water. Silicon dioxide is quartz, and it's also glass. Quartz crystal is extremely organized. Do you see that one over there on the left? You see how organized the molecules are into those star tetrahedrons? That's how quartz crystal's aligned. See the one on the right with no order to it at all? That's what glass is. Glass and quartz crystal are the same stuff. Can you use glass for computer chips? Because it has no formation, therefore it doesn't have information. Does that make sense? Whereas quartz is the same exact ingredients, different formation to it. That's why if you drop glass, it just shatters. But if you drop a quartz crystal, it cleaves along fracture lines, and you get these straight lines in its fracturing. Does that make sense? Because when you break it, see if you broke that one on the left, how it would break in an orderly way? That's called cleavage. Crystals do that. Glass is disorganized. It breaks and shatters. Everybody with me on that? That's an analogy. I want you to just think about what the structure of water's like. See how organized that is? See how crystalline that is? Okay, I want you to think about this. That's probably 32 degrees Fahrenheit or 0 degrees Celsius, right? It's frozen. Imagine that we started to heat that up, liquefy it, just barely. Would all that order just disappear suddenly? Or would it sort of maintain itself, but it would sort of maintain itself like a flow? It's kind of like if we got a whole bunch of people up here and we all stood like a chessboard, really organized. And then we all started to move, but we held on to some of that order. Does that make sense? That's what liquid water can be. Can be a liquid crystal. Here's a little depiction of that. So on the far left, you have solid state water or ice, and then liquid. Now, when water becomes a gas, and you've seen this because you've boiled water before, and you've seen what happens with steam, that's when the water leaves that bonding and disappears into the atmosphere. That's how you disorganize water. That's how you erase the crystal. Does that make sense? But if you can maintain some of the structure of water, you can make a liquid crystal out of it. Water can store information in the crystal. Who's heard of homeopathy? Homeopathy is where you take water and it has a medicinal effect, essentially, because somebody put information in the water. It's been around since the 1700s. Here's how that works. If that sounds totally hokey to you, here I'm going to give you a little analogy. Is there a hand there? Is there a human hand there? Is there a physiological flesh and blood hand there? But there's a hand there, right? It's the memory of a hand. The memory of a hand is stored in the organizational pattern of those little individual parts. Right? If that thing was totally disordered, it couldn't hold on to the information of the hand. But because it's orderly, you can store the memory of the hand in it. Water that's highly crystalline can remember things. That's how homeopathy works, and that's how the future of many of our computer technologies are going to work. In the same way you can use silicon dioxide, they're going to be able to use water to do the same thing. Everybody with me right now? Yeah. Cool. I really believe that our bodies are designed to drink and consume and be built out of crystalline water because we were all drinking water from the ecosystem, water that had never been polluted, water that never had a bad memory. Water that was organized in deep aquifers and brought to the surface of the earth. And the reason that we like to settle our towns around springs, and that's why if you get out a map of the United States or Canada, and you look at the names, you see a lot of like Manitou Springs, Colorado Springs, the town where I grew up, Springvale. Because people like to be around springs because that was the highest, most ordered water, and that makes you feel the best. Everybody with me on that? But right now, what we're doing, and you know, I was talking the other day, hinting the other night about wild food, and talking about my experiences with wild food. And what I've come to understand is there's such a thing as wild water. And that just sounds very funny to people because we've been taught to see all water as the same. And if you look in your own mind, you'll see you were taught to see all water as the same. Boiled water is the same as dehydrated. Distilled water is the same as RO water. All water is the same. And the only way we think about water is this has got stuff in it or not. When we ask if a water is a good water, we mean is there stuff in it? Or is it clean? There's a whole nother story we haven't thought of. Does it have information in it? Or has it been erased? Does it have good information in it, or does it have bad information in it? Does that make sense? That's a qualitative difference, not a quantitative difference. We've been in a world of quantifying chemicals, so we think, is there dirt in this? Is there chemicals in this? Is there fluoride in this? Is there chlorine in this? Well, guess what? You can take the hand away and still have the hand memory. You can take the chlorine away, but maybe you still have the chlorine's memory. And just in the same way that your mind is seeing a hand that's not there, your body might be experiencing chlorine that's not there. Does that make sense? And rather than drinking wild water, and I want to put this into the collective mind, we've been drinking processed water. Right? We think about processed food, and we're very comfortable with that idea now. Right? Your great-grandparents, processed food wasn't a bad thing. And there's a reason for that we're not going to get into, but it wasn't a bad thing. Today, we hear processed food, we're like, oh, that's not good. We need to get ahead in our thinking and realize that water's being processed a lot too. Tap water, processed. Bottled water, most of it, processed. Filtered water, processed. Processed, right? Does that make sense? It's not water from the ecosystem. It's water from the ecosystem at some point that's been through some kind of processing and changing, and then we end up drinking it. So let's talk a little bit about processed waters. Yo. Just make the commitment now. If you're not on a well, if the water coming out of your tap isn't from your well, if you don't live in one of the rare places like Mount Shasta where the whole town gets spring water right through their pipes with no treatment, if you don't live somewhere like that, just stop with the tap water. In fact, you don't even have to call it tap water. You can call it tap liquid. What's some of the problems with it? Well, we know there's a poison in it. There's no question that stuff's poisonous. We know it's poisonous. It's an antibiotic. Now, there's a reason we put it in there, and we put it in there because if we didn't, you would get water delivered to your tap that had organisms in it, and we would have food poisoning 3 times a week. Like what happens if you go down to Mexico as an American, with our sensitive little gut tubes. We go down there, we start drinking the water. You know what happens. So we put chlorine in it, that kills off the organisms. Unfortunately, that's kind of like using antibiotics on yourself. It's kind of like using hand sanitizer. You get like an immediate benefit, but you get a long-term problem. That's that we start living in sterile environments, and the stuff we're consuming is sterile. It's becomes like a medical grade water. And you wouldn't want to put yourself in a pool of chlorine. You'd burn up. But over time, what you're doing is the same if you're consuming tap water, right? Or if you're showering in it. So one of the interesting things is chlorine is toxic and dangerous. It's caustic. It burns things. But what's toxic is the byproducts of trihalomethanes, which are what happens when chlorine burns up something organic. When it kills something in the water, it produces a carcinogen. Those are chloroform, bromoform. How does that sound to you, by the way, chloroform? Just not really. Maybe I don't want to drink chloroform. Or dichlorobromethane. So these are carcinogens that are the result of chlorine doing what it's there to do. And they're volatile. That means if they get warm, they go airborne. And that means that your shower can become like a gas chamber. You get in the shower, right? So you go in, you close the door. Then you get inside the shower and you draw shut that thing. You make a little chamber. Because if you don't, it's kind of cold in there. So you make a little chamber. Then you heat up chloroform till it becomes an airborne chloroform gas. And you gas yourself in chlorine. And you absorb far more through the lungs than you would from drinking it. So the amount of chlorine that ends up in your blood from one shower is about the equivalent of if you drank 8 glasses of chlorinated water. Every morning. Every morning. And all of the organisms who live on your skin, who are your external immune system, keeping you healthy from organisms that would land on you, get treated with antibiotics every morning. Oh. What do we do? Well, here's where you start. Get a shower filter. Go over. Is it Amika who has them right now? Go get one. So if you live in a place where you have municipal water, just no, it's a no-brainer. The amount of the investment, just get one. And you'll notice in 2-3 days, your skin and hair, you'll notice the difference. It's not perfect. It doesn't take everything out, but it makes a difference. Okay, so chlorine's in there for a reason, so we don't get sick initially. We don't know what it's going to do long term. We are the experiment generation. I know personally, as having been a lifeguard, that I would watch the swim team come in where I was sitting every day, and they would start the season with a red pair of Speedos, and they would end the season with a pink pair with holes all in it, because chlorine eats it. We don't know what it does to us long term. It's in there for a reason, and to some degree. There's better methods. That's what we're using. The bigger issue, though, whoa. Fluoride. Hey, fluoride's good for our what? Yeah, shout it out. It's a program. Is it good for our teeth? Is it a neurotoxin? Was it first discovered in Russian prison camps that it created docile, passive populations? Was it then picked up by the eugenicists in Adolf Hitler's SS and used in their prison camps to make those populations docile as well? And then was it put into our water supply? So we're being drugged. Not every municipality, but most municipalities are drugging their people with a drug that if a doctor wanted to give to you, you would need a prescription, you would need to sign off on a waiver. It's a neurotoxin. It's just being put in your water. And who went to school and got fluoride tablets put in their mouth? Who got that? See, look around. Everybody hold your hands up if you were. If it's getting in teeth are a modified what? Bone. So if it's in the teeth, it's in the bones. Does that make sense? And what happens is fluoride stores itself up. So even if you stop drinking fluoride or using fluoride toothpaste, which you should stop using, even if you stop, there's a period of time where there's still fluoride being released into your blood every day as your body tries to detoxify it, so it sort of stays with us. By the way, best way to get it out, getting it out of your life, drinking clean water, and getting in those infrared saunas. Sweating is what takes that stuff out of your body. You need to sweat, you need to drink clean water, and wash that fluoride out, and watch you get your life back. Here's why. What's the number one target for fluoride in your body? Number one place it goes. The pineal gland. Not your teeth, not your bones. Number one target is your pineal gland. Your pineal gland is your third eye. That's why it creates docility in populations. It attaches itself to calcium in the pineal gland. You know the average adult's pineal gland is completely calcified by age 18. Here's a study about it. After half a century of the prophylactic use of fluorides in dentistry, we now know that fluoride readily accumulates in the human pineal gland. In fact, the aged pineal gland contains more fluoride than any other normal soft tissue. You just got to get off tap water, especially if you live in a place that fluoridates. If you don't know, call up your municipality, ask if they fluoridate the water. If they do, you need to be really thoughtful about that. Here's the thing, I'm not really that big into, here's why I'm not into filters. You know, who makes Brita? Clorox. We put it in, we take it out. 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 It's so sketchy. What does that even mean? You know, just go get a box. Look, if your current water strategy is using a Brita filter or a pure filter, you've made a step beyond where the average person is, and I commend you for that. And if that's where you're at, I want you to think, wow, what's the next level for me? Because if you really pick up the box and you look on the side, it says, removes the smell of chlorine. Removes the smell. We call it the water Febreze. It really doesn't do anything. Now, if you were, say, collecting well water and you wanted to filter out sand particles or something, that would be great. But don't delude yourself and think it's taking fluoride out. It's not taking fluoride out. It's not really even taking that much chlorine out. And it certainly isn't taking out the pharmaceuticals that are showing up, the 55 pharmaceuticals that are in the water supply here in LA. You know what I'm talking about? By the way, why is there pharmaceuticals in the water here? Urine. Yeah, because they recycle urine into drinking water. Just so you know. Just putting it out there. Reverse osmosis filters, also not my favorite. Here's a couple reasons. Water molecules are pressed through a very fine membrane, very fine. So fine that basically everything gets left behind and only water can get through. That's a really fine screen, right? It's pretty impressive. Water goes through that, but what happens to a water structure if you're separating all the molecules? You scramble and disassemble that whole structure. So it has maybe the handprint of a good ecosystem, and it goes through. Now, what's good about that is if your water's got a really toxic memory, like it's LA tap water, and it goes through that, you can erase a lot of the memory of that by disassembling the water. But what comes out on the other end has no structure to it. And it doesn't, who's ever drank for any period of time water from a reverse osmosis filter and notice, wow, I cannot get hydrated from this. No matter how much of this I drink, I'm not really hydrated. I'm like, I still want to eat oranges every day because I feel like I'm not getting any good water. It will keep you alive. You can certainly survive on it, and I don't want to make it like you can't. If RO is what you're using, what's great about it, when your filter's new, it probably takes out your fluoride. When your filter's a couple months old, it doesn't. What I don't like about RO is that an average RO unit that gives you 5 gallons of water wastes 40 to 90 gallons. That, you can see how that's a very wasteful way to treat water. 90 gallons for every 5 you get is washed out into the sewage system and mixed with pee and poop and then recycled back into your, it's just like not a great way. So that's not my personal strategy. What I've gotten into is spring water. I like water that comes from aquifers because I trust it. Because I know that it's thousands of years old, because I know that it's clean, because I know most of the aquifers are currently unpolluted, and I can trust it. By the way, I want you to know this. Most spring companies today do not deliver you bottled spring water. They deliver you bottled well water. Poland Spring, where I live, one of the most popular spring water in the United States, is 10 wells. Their spring is dried up. Fiji water, what's it come from? Fijian well. And it's a great water, but it's from a well. So I just want to say you probably wouldn't pay $5 for it if it said Fiji well water. See how it's different? Do you feel that? Oh, well water. Oh, geez, I'll go get my own well water. They send well water from Fiji? Voss water. That's another beautiful bottle. I like that bottle a lot. Where's that water come from? It comes from an artesian well. It's a well water. Most of them are wells, and in fact, they've lobbied to have the law changed so that if you have a well basically near a spring that used to be there, you can call it a spring water. They changed the definition. The only state that won't allow that is North Carolina, but that's only for their own water manufacturers, but they can sell any other water, so it doesn't even matter. So basically, the whole country is selling well water, calling it spring water, and we go buy these. And I know you guys know most of the waters out there, like Dasani's, and like Aquafina, that you're really buying Coke and Pepsi water, and that they're not spring water at all. They're just municipal water. It's filtered. I know you know that, but I want you to know that even if it says spring water on it, it's likely it's from a well. Yeah, I'm going to tell you about raw water. And there are some exceptions. Mountain Valley is an exception. That's an ancient, old source. It's a hot spring. What's that? Mountain Valley, the water that's been here in the green glass, Mountain Valley. That's another exception. Okay, here's the way they process spring water, though. Even if you do get a good spring water, I want you to know it's been processed. Here's how it's been processed. Ozone to kill off any organisms that are in it. So they pump ozone through the water. They use UV light, so they pump UV light through the water. That kills off, actually doesn't kill things. You know what UV light does to things? It damages the DNA so the thing can't reproduce. So all the algae in the water then have damaged DNA. Let me think. Wow, cool. Now they do that for one reason. They do that to give shelf stability to the water. So when you buy even a good spring water, it's been sterilized. It's been sterilized, and that's to keep it fresh on a shelf. Now, the water, by the way, from springs has been underground for a really long time, centuries, millennia. And it's been underground since in industry, but when it comes to the surface, it brings with it the seed of life. We're going to talk about that in a second. So I want to give you guys a mission. Please, where you live or where you travel, if you remember a spring from your childhood, if someone around you knows about a spring, if you find a spring, please go to the website, hit the submit button, and add that spring on. You can name it if you want. You can put up pictures. You can put up video. If you want to put up data like what its pH is, or what its anything you want, directions, and then it's there for other people to use.